Our life supports air around us. Human beings cannot live without air for more than a few minutes. All living things need air to breathe. The thick blanket of air that surrounds our planet is called the atmosphere. The atmosphere is held around the Earth by its gravitational force. The atmosphere has the air we breathe, the wind and rain, and the clouds in the sky. It is life-giving. The atmosphere prevents the Earth from becoming too hot or too cold. It blocks out the harmful rays, ultraviolet radiation, of the sun. The atmosphere also prevents meteors from hitting the surface of the Earth. The oxygen present in the atmosphere supports life. In places such as high mountain tops or deep in seas and oceans where there is not enough air or oxygen, we need to carry oxygen cylinders for breathing. Air also contains carbon dioxide, which plants use to prepare food. Other uses of air. Moving air can support parachutes, gliders and kites. Air is used to inflate footballs and tubes of vehicles. It can also push sailboats, turn the blades of a windmill to draw water, or generate electricity. Air is needed for breathing. The fresh air we breathe in is called inhaled or inspired air. The air we breathe out is called exhaled or expired air. In our lungs, oxygen from the inhaled air is taken by the blood. Carbon dioxide from the blood is given out with exhaled air. Exhaled air has a higher percentage of carbon dioxide than inhaled air. It is also warmer than inhaled air. Layers of atmosphere. The atmosphere is divided into 5 layers. Troposphere is the first layer above the Earth's surface. Changes in the weather occur in this layer. Stratosphere is the second layer. Jet aircrafts generally fly in this layer. Ozone gas is present in this layer. Ozone absorbs harmful ultraviolet rays of the sun. These rays can cause skin cancer. Mesosphere is the third layer. Meteors or the small rocks moving about in space burn out in this layer and therefore do not reach the surface of the Earth. Thermosphere is the fourth layer. Space shuttles move about in this layer. Exosphere is the fifth layer of the atmosphere. Air is needed for burning. Air contains oxygen, which is needed for burning. Experiment I. Fix 3 candles on a table and light them. Cover the second and the third candle with glass jars. The glass jar on the third candle should be bigger than the one over the second. What do you observe? Air is needed for blank. More air allows the candle to burn blank. Composition of air. Air is a mixture of various gases. Clean air consists of about 78% nitrogen, 21% oxygen, and less than 1% of argon, carbon dioxide, and other gases. Air contains water vapor, dust and smoke, whose percentages vary by place and time. Argon is used to fill common electric bulbs and is seen in neon electric lights. Oxygen. Oxygen is the most important gas for the survival of living beings, who need it for breathing. Oxygen is also essential for burning. Nitrogen. Living beings do not use nitrogen directly from the air. Plants obtain nitrogen with the help of bacteria in the soil. Nitrogen is also added to the soil through chemical fertilizer. Animals acquire nitrogen from plants, meat, and fish. Carbon dioxide. Carbon dioxide is an important gas for plants. Plants use carbon dioxide, water, and sunlight to prepare their food through photosynthesis. Other gases. Other gases like argon, ozone, helium, and neon are also present in the air. Water vapor. Water is present in the air as water vapor, which forms through evaporation from seas, rivers, and lakes. Water vapor forms clouds and then condenses to fall as rain or snow. The amount of water vapor in the air is known as humidity. High humidity indicates a very humid environment and makes us feel uncomfortable because sweat does not evaporate easily. Properties of air. This section discusses the main properties of air. Experiment 2. Take water in a glass tub or container. Then invert an empty tumbler and dip its rim into the water to see if water enters the tumbler. Lower the tumbler into the container. Why does the water not enter the tumbler now? Tilt the tumbler to one side. What do you observe? Tilt the tumbler still more. More air bubbles will come out and the water will fill the tumbler. Experiment 3. Blow air into two balloons of the same size and tie them at the two ends of a stick. Balance the stick by shifting the positions of the balloons as shown in Fig. 3.5. Now prick a balloon and let the air escape from it. What happens when all the air escapes? The stick tilts towards the air-filled balloon. What does this experiment show? Only then does the liquid start flowing in. Try sucking through a straw with a hole near its top. Experiment 4. Take a glass tumbler and fill it with water to the brim. Make sure that there are no air bubbles in the tumbler. Cover the tumbler with a piece of stiff paper. Press the paper with your hand and turn the tumbler upside down. Remove your hand and observe. What happens? What will happen if the glass is not filled up to the top? What does this experiment show? Air exerts pressure. Since air has weight, it presses downward. As we go up a mountain, air pressure reduces. The air pressure at sea level averages about 1 kg per square cm. We make use of air pressure in a doctor's syringe, for filling ink in a pen, or sucking liquid through a straw. In all these cases, first we force the air out. Experiment 5. Take an empty plastic bottle and make a hole on its side. Seal the hole with sellotape and fill the bottle with water. Open the hole and observe what happens. Seal the hole again and fill the bottle with water. Screw the cap of the bottle tightly. Open the hole. What happens? What does the experiment show? Experiment 6. An experiment showing how air pressure from an inflated balloon inside a tin can lift the tin lid. Demonstrating air exerts pressure. Air exerts pressure in all directions. Water too supports life. Water is essential for survival, drinking, cooking, bathing, washing, and construction. Rainwater is the purest natural form of water, but it can contain dissolved substances, dirt, and other impurities. Water must be purified and made suitable for drinking. Impurities in water. Water in wells and rivers contains impurities. Impurities can be insoluble, visible, soluble, invisible, or disease-causing germs. Experiment 7. Observe what happens when salt, sugar, sand, copper sulfate, gravel, tea leaves, and talcum powder are added to water in a test tube. Some solids dissolve in water to form a solution, while others do not. Identify which of the tested solids dissolve in water to form a solution. Removal of insoluble impurities. Insoluble impurities can be removed from water through sedimentation and decantation. Experiment 8. Mix soil in water, stir, and let it stand. Heavier soil particles will settle down. Sedimentation. Carefully pour the clean water from the top into another beaker. Decantation. We can also separate soil from water by using a filter paper. This process is called filtration. Fig. 3.9. Experiment 9. Make a circular filter paper cone by following the steps shown in Fig. 3.9a. Then place the cone inside a funnel over a beaker. Pour the mixture of soil and water over the filter paper using a glass rod. Fig. 3.9b. Clear water, filtrate, will trickle into the beaker, while soil particles, residue, will be left on the filter paper. Experiment 10. Dissolve 2 teaspoons of salt in water in a beaker. Heat some of this salt solution in a dish to observe water evaporating and leaving salt behind. Evaporation is the process of changing water or any other liquid to vapor by heating, though all the water is lost. Distillation is a method that separates soluble impurities from water. During distillation, impure water or solution is heated until boiling, causing the water to evaporate. The water vapor then enters a cool condenser, circulated by cold water, where it changes back into liquid water. Distilled water, the purest form free of impurities or germs, is collected in a flask. The impurities that were dissolved in the water are left behind in the heating flask. Distilled water is mainly used in car batteries, science experiments, and medicines. Removal of soluble impurities. Soluble impurities can be removed from water by evaporation and by distillation. Purification of drinking water. For healthy living, clean water is necessary for drinking and cooking. Impure water contains many disease-causing germs like those of cholera, jaundice and dysentery. In cities, the water supplied to the public is filtered and purified before being piped for domestic use. Sedimentation, filtration and chlorination are the 3 main methods used for cleaning water. In sedimentation, water is collected in large tanks and left undisturbed for a few days, allowing heavier suspended impurities to sink. Air and sunlight kill harmful bacteria, and chemicals like alum are added for further purification. After sedimentation, water is filtered through a clean sandbed to remove finer suspended particles. In chlorination, water is disinfected with a small quantity of chlorine gas to kill bacteria, making it safe for drinking. Keep drinking water clean. Water can be purified and made fit for drinking by using the following methods. Boil water for at least 10 minutes. Boiled water may be strained through a clean piece of cloth and stored in a clean container. Use a water filter and clean it regularly, as a dirty filter can be a breeding ground for disease-causing germs. Add potassium permanganate crystals into wells for killing germs. Underground water from deep springs and wells is usually free from insoluble impurities and safe to drink. Words to know. Atmosphere, the blanket of air surrounding the Earth. Gravitational force of the Earth, the force by which the Earth pulls an object towards it. Humidity, amount of water vapor present in the air. Distillation, purification of a liquid by changing it into vapor by heating and then condensing it into a pure liquid by cooling. Chlorination, method of disinfecting water with a small amount of chlorine gas. Quick recap. The blanket of air surrounding the Earth is called atmosphere. The 5 layers of atmosphere are the troposphere, stratosphere, mesosphere, thermosphere and exosphere. Air is a mixture of many gases like nitrogen, oxygen and carbon dioxide. Air occupies space, has weight and exerts pressure. Water can be purified by sedimentation and decantation, filtration, evaporation or distillation. Disease-causing germs can be killed by boiling water or by adding chlorine to it.